أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنستعرض موضوع جديد من موضوعاتنا وهو behavior of a functions. هنستعرض النهاردة إن احنا لو رسمنا فانكشن أو شفنا أي رول لأي فانكشن نقدر نتعرف على البيهيفير بتاعها. الفانكشن دي increasing، الفانكشن دي decreasing، الفانكشن دي convex upward convex downward، امتى بقى ليها لوكال ماكسيمم فاليو، امتى ليها لوكال مينيمم فاليو. كمان نقدر نعمل سكتشنج او نرسم الكيرف بتاع الفانكشن دي بمجرد ما نشوف شكل الفانكشن مستخدمين موضوع الديريفيتيف اللي احنا سبق وتعلمناه قبل كده. Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today is behavior of a function. Let's start with increasing and decreasing functions. Increasing and decreasing functions. Definition: if f of x2 greater than f of x1 where x2 bigger than x1 for all x1 and x2 belongs to the open interval a and b, in which the function f is defined, we say that f is an increasing function on the open interval a and b. Now, the graph of this function f of x is a function on the open interval a and b, and we choose x1 and x2, two values belongs to this open interval. x1 smaller than f2, then the value of f of x1 smaller than the value of f of x2, or x2 bigger than x1, then f of x2 bigger than f of x1, then this function is called an increasing function on the open interval a and b. If f of x2 smaller than f of x1 where x2 bigger than x1 for all x1 and x2 belongs to the open interval a and b, in which the function f is defined, we say that the function f is an decreasing function on the open interval a and b. If we draw the graph of this function from a to b, open interval a to b, and x2 bigger than x1, then the value of f of x2 smaller than the value of f of x1, then this function is a decreasing function on the open interval a and b. Now, we can deduce the following theorem by using the first derivative to find the increasing and decreasing intervals. Theorem: let the function f of x is the differentiable function in the open interval a and b. In the case of increasing, number one, if f of x is increasing on this interval, then the first derivative of the function, which is f dash x bigger than 0 for all x belongs to the open interval a and b, and if f dash x bigger than 0 or positive in the open interval a and b, then the function f of x is increasing on this interval. But in the case of decreasing, if the function f of x is decreasing on this interval, then f dash x smaller than 0 or negative for all x belongs to the open intervals a and b. And if f dash x smaller than 0 or negative in the open interval a and b, then the function f of x is decreasing on this interval. Let's start with the first example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals x to the power 3 minus 9x power 2 plus 24x minus 1. The first step, we find the derivative of the function f. f dash x equals derivative of x power 3 is 3x power 2, and the derivative of negative 9x power 2 is negative 18x, and the derivative of 24x is 24, and the derivative of negative 1 is equal to 0 because negative 1 is a constant. Second step, we put f dash x equals 0. Then 3x power 2 minus 18x plus 24 equals 0. By dividing by 3, then x power 2 minus 6x plus 8 equals 0. And we factorize this expression, then x minus 2 multiply x minus 4 equals 0. Then x equals 2 or x equals 4. Now we draw the number line from negative infinity to positive infinity. And the values of x equals 2, x equals 2, and x equals 4. When x equals 2, f dash x equals 0. And when x equals 4, f dash x equals 0. Now we divided the number line by the two values of x, 2 and 4, into 3 open intervals. The first interval, negative infinity and 2. Then in the open interval, negative infinity and 2, f dash 1. 1 is any value belongs to this interval. F dash 1 equals 3 multiply 1 power 2 minus 18 multiply 1 plus 24, which equals 9. 9 bigger than 0 is positive. Then the sign of f dash x is positive, and the function, the behavior of the function f of x in this interval is increasing. The function is increasing in this interval from negative infinity open to open. Now, in the open interval 2 and 4, f dash 3, where 3 is any number belongs to the open interval 2 and 4. Then f dash 3 equals 3 times 3 power 2 minus 18 times 3 plus 24, which equals negative 3. Negative 3 less than 0 is a negative value. Then the sign of f dash x in the open interval 2 and 4 is negative. And we can say that the function is decreasing in this interval. The last interval, open interval 4 to infinity. We choose any number belongs to this interval like 5. Then f dash 5 equal 3 times 5 power 2 minus 18 times 5 plus 24 equals 9, which bigger than 0. 9 is a positive value. Then f dash 5 is positive. The function, the sign of f dash x is positive, then the function is increasing in the open interval 4 and infinity. The 2 points 2 and x equals 2 and x equals 4 have a critical point. Then when x equal 2, then f of 2 equal 3 multiply 2 power 3 minus 9 multiply 2 power 2 plus 24 times 2 minus 1 equals 19. Then f of x equals 19. And the point 2 and 19 is a critical point. And when x equals 4, f of 4 equals 3 multiply 4 power 3 minus 9 multiply 4 power 2 plus 24 multiply 4 minus 1 equals 15. Then the point 4 and 15 is a critical point. Now we move to the next example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals 5 minus 2 multiply e to the power 2x. Now we have exponential function. f of x equals 5 minus 2 e power 2x. The domain of this function is R. Then f dash x equals the derivative of 5 equals 0 because 5 is a constant, and the derivative of 2e power 2x is 4e to the power 2x. E power 2x times 2 times 2, which is equal negative 4e power 2x. The second step, put f dash x equal 0, then negative 4e power 2x equal 0. This equation has exponential function e power 2x. Then the equation has no solution in R because the exponential function is positive. Then f dash x smaller than 0 for all values of x, or for each x belongs to R. Then the function is decreasing on its domain R. Another example. Find the intervals of increase and intervals of decrease for the function f, where f of x equal 3 minus log x power 2 to the base e. Now we have logarithmic function f of x equals 3 minus log x power 2 to the base e. The domain of this function is R except 0. Then f dash x equals negative 2 over x because the derivative of 3 equals 0 and the derivative of log x power 2 to the base e equal negative 2 over x. The second step, put f dash x equal 0, then negative 2 over x equals 0, and this equation has no solution in R. Then we can draw the number line. The number line from negative infinity to infinity. And x equals 0. And f dash x equals undefined because log x power 2 to the base e has no value when x equals 0. In the open interval negative infinity and 0, f dash negative 1 equals negative 2 over negative 1 equals positive 2. Positive 2 is positive, bigger than 0. Then the sign of f dash is positive. And the function f of x is increasing in this interval. And in the open interval 0 to infinity, f dash 1 equals negative 2 over 1 equals negative 2, smaller than 0, then f dash 1 is negative in this interval. And the function f is decreasing in the open interval 0 and infinity. Then the graph of the function 3 minus log x power 2 to the base e is increasing in the open interval negative infinity and 0 and decreasing in the open interval 0 and infinity. Another example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals x plus 2 sine x, where x bigger than 0 and smaller than 2 pi. Now we have a function, sum of two functions, x and 2 sine x. X is a polynomial function and 2 sine x is a trigonometric function. Now f dash x. Note that this function is continuous and differentiable on the open interval 0 and 2 pi. Then f dash x equals 0 when f dash x equals 1 plus 2 cosine x equals 0. Then cosine x equals negative half, and don't forget that x belongs to the open interval 0 and 2 pi. Then x equals 2 pi over 3 or x equals 4 pi over 3, where cosine is negative, then the function lies in the second quad or the third quad. In the second quad, x equal 120 degrees or x equals 2 pi over 3 in rad measure. And x in the third quad equals 240, which is 4 pi over 3 in rad. Then we draw the number line from negative infinity to positive infinity, and remember that the domain of the function, the values of x belongs to the open interval 0 and 2 pi. When x equals 2 pi over 3, then f dash x equals 0. And when x equals 4 pi over 3, f dash x equals 0. Now we have three intervals. The first interval, 0 open and 2 pi over 3 open. Then f dash pi over 2 equals 1 plus 2 cosine x, cosine pi over 2. 1 plus 0, 1 plus 0 equals 1, which is positive or bigger than 0. Then the sign of f dash is positive in this interval. And the function is increasing in this interval. The second interval, open 2 pi over 3 and 4 pi over 3. F dash pi equals 1 plus 2 cosine pi equals 1 plus 2 multiply negative 1, which is negative 2. 1 minus 2 equals negative 1. Then f dash smaller than 0. Then the sign of f dash is negative in this interval. Then the function is decreasing in the open interval 2 pi over 3 and 4 pi over 3. Now in the open interval 4 pi over 3 and 2 pi, f dash 3 pi over 2 equals 1 plus 2 cosine 3 pi over 2 equals 1 plus 0 equals 0 plus 1 equal 1 bigger than 0. Then the sign of the function f dash x is positive and the function is increasing in this interval. Then we have three intervals for the function x plus 2 sine x. The function is increasing in the open interval 0 and 2 pi over 3 and decreasing in the open interval 2 pi over 3 to 4 pi over 3 and increasing again in the open interval 4 pi over 3 and 2 pi. Now let us discuss the concept of critical point. Definition: we say that the point x1 and f of x1 is a critical point of the function f if one of the following satisfies. Number 1, the first derivative f dash x1 exists and is equal to 0, or f dash x1 doesn't exist or undefined. Then we can say that this point is a critical point in two cases. The first case, f dash x1 exists and is equal 0, or f dash x doesn't exist or undefined. Now, if the curve of the function f, where f of x equals ax power 2 plus 12x plus 1, has critical point at x equal 2, then a equals 12, or a equals negative 3, or a equal negative 6, or a equal 3. The curve of the function f of x equals ax power 2 plus 12x plus 1 has a critical point at x equal 2. The first step, we find the first derivative of this function. Derivative of ax power 2 is 2ax, and the derivative of 12x is 12, and the derivative of 1 is equal to 0 because 1 is a constant function. Now, the curve has a critical point. then at x equal 2, then f dash x equals 0 when x equal 2, or f dash 2 equals 0. Then 2a multiply x or multiply 2 plus 12 equals 0. Then 4a equals 12, 0 minus 12, then 4a equals negative 12 by divided by 4, then a equals negative 3, then we can choose the answer B. Then when the function has a critical point, then the constant a must be equals negative 3. Dear students, we can discuss the following concept: local maximum and local minimum. If we draw a curve of a function like this function, and we discuss the behavior of this function in the open interval a and b. Note that the function is increasing from a to x1 and decreasing from x1 to x2 and increasing again from x2 to x3 and decreasing from x3 to x4 and increasing from x4 to b. This function is a continuous function. We can say let f is a continuous function on the open interval a and b and is graphically represented by the above figure. We note that if f of x1 bigger than f of x for all x lies on the left and the right of x1, therefore we can say that f of x has a local maximum value at x1. The function is f dash x is positive or is bigger than any value of x on the left or on the right of x1, then the function has local maximum value at x1. And if f of x2 smaller than f of x for all x lies on the left and the right of x2, therefore we can say that f of x has a local minimum value at x2. Then we can, using the derivative, to find the local maximum or local minimum values of any function by using this theorem. Let the differentiable function f of x is defined on the open interval a and b, and x1 belongs to the open interval a and b. If the function f has a local maximum or minimum value at x1, then f dash x1 equals 0 or f dash x1 not exist. Note, if the function f is differentiable at x1 and the first derivative equals 0, f dash x1 equals 0, then it's not necessary that x is a point of local maximum or local minimum. For example, f of x equals x to the power 3. And another note, it may be happen that x1 is a local maximum or local minimum of the function f and f dash x doesn't exist. For example, f of x equals absolute x. Find the local maximum and the local minimum values of the function f, where f of x equals 4x over x power 2 plus 4. The function f of x equals 4x over x power 2 plus 4 is a quotient and its domain equals R. F dash x equals 4, which is the derivative of 4x, multiply x power 2 plus 4 minus 2x, which is the derivative of x power 2 plus 4, multiply the numerator 4x, all over x power 2 plus 4 all power 2. We can write this function f dash x as 4x power 2 plus 16 minus 8x power 2 all over x power 2 plus 4 all power 2. Then f dash x equals 16 minus 4x power 2 over x power 2 plus 4 all power 2. The second step, we put f dash x equals 0, then the numerator 16 minus 4x power 2 equals 0. And we can write 4x power 2 minus 16 equals 0 and divide by 4, then x power 2 minus 4 equals 0. This expression is the difference between two squares, then the two brackets x minus 2 times x plus 2 equals 0 and x equal 2 or x equals negative 2. Now we draw the number line from negative infinity to infinity and x equal negative 2 and the value of f dash 2 negative 2 equals 0, and when x equal 2 f dash x equals 0. Now in the open interval negative infinity and negative 2 f dash negative 3 equal 16 minus 4 multiply negative 3 power 2 over negative 3 power 2 plus 4 all power 2, which equals negative 20 over 169, and this value is smaller than 0, or f dash x is negative in this interval, then the function f of x is decreasing in this interval. In the open interval negative 2 and 2 f dash 0 equals 16 minus 4 times 0 power 2 over 0 power 2 plus 4 all power 2 equals 16 over 16 equals 1, which is bigger than 0. Then f dash x is positive in this example and the function is increasing in the open interval negative 2 and 2. In the last interval, open interval 2 and infinity, f dash 3 equals 16 minus 4 times 3 power 2 over 3 power 2 plus 4 all power 2, which equals negative 20 over 169, smaller than 0, and the function is decreasing in this interval. When x equals negative 2, it's a point of local minimum value, and when x equals 2, it's point of local maximum value. بكده أعزائي نكون استعرضنا مع بعض موضوع increasing and decreasing of a function، وكمان شفنا ازاي نقدر نتوصل ل critical point ونعرف إذا كانت البوينت local maximum or local minimum value عن طريق استخدام the first derivative of the function. By this example we come to the end of our program today. Till we meet again, it's goodbye.